Today I am going to talk about the resistance of the wires, resistance of the conducting materials. Often in in electricity chapter, the term resistance is used. Now in this particular presentation, we are going to learn about the meaning of resistance. In Tamil it is called as min tadai. Are you clear? What is resistance? Here I have taken two wires. One is made up of nichrome and another one is made up of copper. When current passes through these conductors, through these wires, what will happen? The current will be opposed by the materials. When current passes through the nichrome wire, what will happen? The nichrome material will oppose the flow of current. The opposing nature of the material is called as resistance. Both of them will oppose. Copper also will oppose the flow of electricity and nichrome also will oppose the flow of current. But here what happens? The resistance offered by the copper will be less. The resistance offered by the nichrome will be more. Though they have same length, depends on the nature of the material, the value of resistance will also change. So the resistance of the wire or resistance of the conductor, that depends on the nature of the material. As I have told earlier, copper will offer less resistance and nichrome will offer more resistance. Whenever you want to get any high resistance value in any appliance like heaters and also in geysers, these kind of nichrome wire must be used. Nichrome, it is used as a heating element. Whenever current passes through nichrome wire, because of offering greater resistance, heat will be produced. If you want to get heat due to the flow of electricity, the nichrome can be used as a heating element. So among the two wires, which one offers more resistance? Nichrome will offer more resistance than copper. Nichrome is an alloy. Nickel and chromium, if both are mixed together with appropriate proportion, you will get a new kind of alloy called nichrome. This one will offer more resistance. Now I am going to measure the resistance of both the two wires. Look at here, with the help of the digital multimeter or digital voltmeter, we are able to measure the which one, the resistance of both the two wires. It's very interesting one. You should know about the device. So whenever this instrument is used, you should know how to use the instrument. Are you clear? So with the help of the probe, we are able to measure the resistance. Here the red probe and black probe both are there. Now I am going to measure the resistance of the nichrome wire first. Just you keep the probe on two end of the wire, you are able to measure the resistance very easily. Are you clear? So just you keep it here, look at the value of resistance. The resistance is around 1.4 ohms. 1.3, 1.4 ohm is the resistance of the nichrome wire. Now I am going to measure the resistance of the copper wire. The resistance of this wire is how much? 1.4 ohm. Now I am going to measure the resistance of copper. Copper will offer very less amount of resistance. Okay, so look at that, 0.3 ohm, 0.3 or 0.2 ohm, almost it is equivalent to 0. Are you clear? So the probes must be kept properly. Are you clear? Only then you are able to measure the resistance. On copper wire there is a coating. Are you clear? Because of the coating, the resistance may not be shown appropriately. The resistance to be measured after the removal of the coating. The resistance of the copper wire is 0.2 ohm. Nichrome wire resistance was 1.3 ohm. So compared to nichrome, the resistance of the copper is very less. Are you clear? That's why the copper, it is used to connect all the appliances in the home. Refrigerator, TV and the tube light, bulbs, fans, everything is connected with the help of copper wire. because it offers less resistance. So depends on the material, resistance value will change. So we have seen the first factor, that one determines the resistance. Depends on the atmospheric temperature also, outside temperature also, the resistance of the wire will change. Are you clear? Next we are going to concentrate on the next parameter. Are you clear? Temperature, that depends on the temperature, the resistance will change. The third parameter is length. Are you clear? Now I am going to take the same substance. Are you clear? Same substance, both are made up of copper. Are you clear? This is also made up of copper. The next wire is also made up of copper. Are you clear? Just look at, in the first wire the length is more, therefore resistance of the first copper wire will also be more. In the case of second one, the resistance is less because the length of this wire is less. Though they are made up of same material copper, since the length is more, resistance of the wire will also be more. You clear? Whenever current passes through the conductor, what will happen? This one will offer more resistance because of its greater length. This one offers less resistance. Since the length is less, resistance will also be less. So the resistance, it is directly proportional to the length. The meaning is, when length is more, resistance will be more. When length is less, resistance will be less. Understood? So this is second parameter, third parameter. Now we are going to see the another thing, that is about thickness or area of cross section. We have to call it as thickness or area of cross section. Now I am going to take the same material. Look at that. By mere seeing, you are able to observe which one is thick wire and which one is thin wire. This is thin wire. This one is thick wire. This is made up of copper. This is also made up of copper. Thick wire, its area of cross section is more. When current passes through this wire, this one will offer less resistance. Thick wire will offer less resistance. Thin wire will offer greater resistance. Are you clear? So when current passes through the thin wire, the resistance will be more. When the current passes through the thick wire, resistance will be less. Therefore, the fourth parameter is area of cross section. How resistance and area of cross section can be related? Resistance is inversely proportional to the area of cross section. When area of cross section is more, resistance will be less. When area of cross section is less, resistance will be more. How these things can be related? R is directly proportional to the length and inversely proportional to area of cross section. Everything is combined here, but they have to be equalized. How to equalize? By introducing a constant. That constant is called rho. That rho is called resistivity. Resistance is equal to that this one to be removed, directly proportional symbol to be removed, that is to be substituted. Is it clear? Here instead of clear, some constant must be introduced after writing the equal symbol. Therefore I have written one constant called rho, that is called resistivity of the material, rho L by A. So this is the formula from which we are able to calculate the resistance of any wire. By knowing resistivity of the material, by knowing the length of the wire, by knowing the area of cross section of the wire, resistance can be measured, and the resistance can be denoted and mentioned with the help of unit called ohm. After calculating all the value, that value must be written along with the unit called ohm. Ohm symbol is omega. Are you clear? Ohm is the unit of resistance. So depends on the material, depends on the temperature, depends on the length of the wire, and also depends on the thickness or area of cross section. Resistance value will vary from wire to wire, from material to material. The symbol of resistance in any circuit, that could be represented by this symbol. You have to draw the zigzag line. After that, on the wire you have to write R. So this is a symbol of resistance. Understood? So resistance is the property of all the conductors. Okay, that is common to all the conductors. Okay, what the conductors they will do? Whenever current passes through the conductor, what will happen? The material will oppose the flow of current. That nature of opposing nature of the conductor to the flow of current is called resistance. In Tamil it is called as min tadai. Understood? So be thorough with the concept. So in future, in verification of Ohm's law experiment, clear, uh, in the place of resistance, this nichrome wire will be used. Don't forget, it's a piece of nichrome wire. That one will offer a considerable amount of resistance. Nuclear, it may have 2 ohm or 3 ohm or 1.5 ohm, whatever it may be. This kind of nichrome wire will be used as a heating element, and also it is used as an unknown resistance. In any Ohm's law experiment circuits, this nichrome will be used as unknown resistance. Its value, that resistance value, that could be found out by using Ohm's law. Don't forget, clear, you have to remember about this nichrome wire. Always this nichrome wire will be used to verify Ohm's law and also to find out the unknown resistance. So very important wire used often in the physics lab. Understood? This one will offer more amount of resistance compared to copper. Understood?